Now that we have completed a couple of tutorials on the control of B6C bridges and generation of different characteristic loads, let's now concentrate on how to calculate the PI controller parameters using Simulink tool. It could also be calculated analytically, but our focus today is on using this tool, and so that we can make our task a little bit easier. To remind you, we had the very basic circuit of the B6 bridge here with the control parameters implemented in the Simulink environment. And you see to the left, we have the AMP file, including the necessary variables that we used in the model. To see the results that for the specified values of Kp and Ki, we had the load current of 1.5 kiloamperes. So on the top window in red, we have the generated current, and in green, we have the reference current. And the lowermost window, we had the generated alpha. And this generated alpha is then the result of the PI controller that then generates, depending on the value of Kp and Ki, these alpha values. Now the motto here is to change these values. This is automatically generated or calculated values from Simulink. So for that, I will just simply replace these values with 1 and see the response of the controller. Let's run it once and see the effect. If we have the scope now, you can clearly see that for this input value of 1 for both of the constants, Ki and Kp, the generated current is definitely not following the reference current. Let's now try to tune these values so that this generated current follows exactly the reference current. In order to tune the Kp and Ki constants, we need to go to the PI controller, double click on it, and when this window opens up, then there is an option called Tune. Let's click on it and give it some time to open. You could see some messages popping up to the bottom, which says unable to perform assignment because the left and right sides have different number of elements. And to the middle, we have another warning, says that plant cannot be linearized. Use the plant menu to create or select a new plant. All we need to do is click on OK and continue. Let's maximize the window. Now, since it's not possible to linearize the model, our option would be to go to the plant here, to the top left corner, and then identify new plant. Click on it, and a second output window pops up to the right. At this point, we need to collect the data, and in order to collect the data, we need to simulate it once. So click again on Simulate Data and give it some time to complete the simulation. But before that, we need to adjust the output window input parameters here, which says the sampling time. I would say let's take it 1 millisecond. Offset, let's take it 0.1. Onset lag or TD, let's take it 0.1, and stop time 1 second is okay. And if you wonder what these values are, then just click on this star, and then you would see a window showing which parameter is representing what. I will take the other default values and click on Run Simulation. What it does, it runs the simulation in the background and identifies the plant. So after that, there are other couple of options here. If you show offset response, you could see if it is following the reference currents. In that case, I would say it is. It ramps up to 1.5 kiloamperes, which was the case for our simulation. For the input response, it also does. So in that case, I would say apply and close. So now the identified plant is shown in blue. After that, what we want to do is then auto estimate. Close this window, apply again. Now you have another window to the left, which shows us the tuned response of the plant and also the block response. Now, if we go to the PID tuner, we have two options with two sliders here. One is representing how fast or slow the plant should respond, or the controller should respond, and how aggressive or robust it should be. So let's adjust these values, like could be slower for, it's not a problem if it is slow, and let's make it robust. Update the blocks. So in that case, it seems a pretty good step response here. I would update the block and see the simulation if the generation of the reference current is successful. For that, let's simulate it once. Okay. At this point, you see the calculated values are sufficient enough to generate the reference current here. So I would say I'm happy with the calculation. If not, you can play around with these two sliders and find the optimal value for you. I'll close this window, and if you go back to the PA controller, you see the calculated values were replaced here. Now we can set them as variables or keep them as they are now. It's up to you. So with these calculated values, we now again have the reference current generated by the converter. So it also could save us a lot of time if we just, instead of playing around with the values, use this PID tuner, and then we can find a solution even sooner. I've said that's all for this tutorial. Thank you for watching.